All right, welcome to Quarantined Math Day 3 in Statistics, which with special guest star Eponine, the Poodle. Sorry for the late videos today, but today in Stats we are going to be working on that packet. We had those exponential equations the other day. You had a couple of them to try out at the end of the day Friday, and we're going to go just a little bit farther in the packet today. So go ahead and go to page 3, 4. In the packet, wherever we left off. We'll do a couple more examples. You'll have another couple problems, and yeah, we'll get that going. All right, so what we're going to be working on today in what will be a pretty quick video is question number 10 on this packet. Question number 10 says the breaking strength Y in tons of steel cable with diameter D in inches is given in the table below, which you can see I have put into the list on the calculator. On the accompanying grid, make a scatter plot of this data. Write the exponential regression equation expressing the regression equation coefficients to nearest 10. Now, I've had a couple of questions on this because this packet specifically talks about rounding. I'll be honest with you guys. I'm not too concerned with the rounding in this packet. If you want to round to the tenths, whole numbers, whatever it is. If we're dealing with numbers that are like these little small numbers, don't just round to the nearest whole number because that would make almost all of these the same. Use some logic there. You can follow the rounding stuff that we talked about in class, but rounding is not my greatest concern. So round however you want on these. What we're going to be doing today is graphing a scatter plot, and I'm going to be going over again. I know several of you have heard this before, but it can bear repeating just in case things sometimes get missed in class. So how we create the scatter plot in here, a really easy way to show that, and then how an easy way to plot it on here would be. So what I'm going to do is to see the scatter plot on the calculator to get an idea of what it should look like. You can put your data in like I did, and then you want to go second y equals. At that point you want to make sure your plot 1 is on and the others are off. This is really important. You'll see right here, it says plot 2 off, plot 3 off. We want to make sure only plot 1 is on. It also needs to have the same lists as you have on your calculator. So mine were in L1 and L2. That's what plot 1 here says, so I'm all good to go. If yours says something different than that, then you can click enter here and then change the X list and Y list to make sure they say L1 and L2. And again, to do that, you hit second, and then you'll see it says L1, L2, L3, so on and so forth above the number keys. So once you make sure you have your stat plot 1 on, you can just hit the zoom button, and then go down to number 9, zoom stat, or just hit number 9 on your calculator, and you see we get a graph. So we want to plot this graph right here. Now, it seems great to just be like, oh, well, we have a dot about there, and there. We want to be a little more specific than that. We want to make a graph like we should be, meaning we are labeling our axes not only with numbers, but also with the variables that they represent, and then plotting the points exactly where they need to go. So here's what I'm going to do. The x-axis, what we put in our L1, is diameter in inches, right? So, the breaking strength Y in tons of steel with the diameter in inches. So, diameter in inches is going to be my x-axis. And then it says the breaking strength in tons is my y-axis. So I know we haven't talked a lot about how to formally do graphs in this class. But anytime we write these or draw these, we really do need to label the axes. And then we're also going to put numbers along here. What we want to do is make sure our numbers are evenly spaced. We have, along the x-axis, numbers between 0.5 and 1.75. We can't just say 0.5, 0.75. Okay, actually, in this case, we could, because these are evenly spaced numbers. But let's say these numbers were like 1, 4, 9, 15. If they were completely different, if they weren't sequential, then we can't just put them one at each space here, right? Because every single block in this graph needs to be an equal distance away from the previous block. So for example, I can start here at, I'm going to space these up by like 0.05 or, going like 0, 0.05, 0.10, that kind of thing. Although I don't think we'll have enough spaces for that. So I probably don't want to start at 0. This is something that sometimes you'll have to realize. It's great to say we'll start at 0, we'll go to whatever the highest number we have is, but we don't always have room for that. We don't always have the ability to start at the lowest value because sometimes these numbers are so far away that we don't have enough space to plot them. Now I still want to go by 0.05, so it lets me space out my graph a little bit, that kind of thing. But what I'm going to choose to do is start somewhere other than 0. And hopefully going by 0.05 I have enough room. That's actually probably going to need me to go like, probably should go by like 0.10, I guess, just to make sure I have enough room here, because going by 0.10 is still going to make me have 13 columns. 0.05 would require me to have like 25, and I don't think I have 25 columns here. So I'm going to go 0.10. So what I'll do is I'll start at like 0.4. The next one can be 0.5, 0.6. Apologies, this is tough to write. 0.7, 0.8, 0.9, 1, 1.1, 1.2, 1.3, 1.4, 1.5, 6, 7, and 8. We don't always have to write every one of those numbers. We can go in intervals. If we wanted to start here, say 0.4 and then 0.6, and then you would just kind of know that the lines in between those are 0.5 or 0.7, the ones we're not labeling. But however you want to do that is perfectly fine. So we've labeled one side. What we want to do now is label the other side. This other side is our amount of tons. This is the one that really goes to show you can't just label one point and then the next. We can't do 9.85, then 21.8 because there's like 11 between those, and then 38 because there's 17 in between those. That would make each block not evenly spaced out. So we have to go all the way up to 114. So I'm going to start at 0 because my number here is pretty close to 0. And then I'm going to just go by tens. So we have 0 right there, 10, and I'm going to do what I was talking about earlier, spacing this out a little bit so we're not quite as cramped, going by 20s here, skipping a line, of course, because we have that line that stands for 100, but we're only writing these every other one. 150, 170. We only have to go to 114, so we're plenty far up on the graph here. So I'm going to graph these points. We have 0.5 and 9.85, so the 0.5 line is right here. 9.8, that would be a point right about there. It's tough because this graph is so small to get that perfectly accurate, but we're in the ballpark. 0.75, that's going to be between 0.7 and 0.8, and that is 21. So this is the line for 20. 0.75 is going to be right about there. Then we see 1 and 38.3. So I have 1 here. 38 is probably going to be a little before that 40 line. 1.25 and 59, so effectively where 60's at. 1.25 will be right between 1.2 and 1.3. Go up to 60 abouts. Right about there. Then we have 1.5 and 85, rounded, of course. So, right here. And then finally, 1.75 and 114. We get right about here. And I think I've stayed in line with that. So we can see that we do have what looks like beginnings of an exponential curve. It's increasing pretty slowly here, but then we start seeing larger and larger gaps in between the dots vertically. And then this problem also wants us to find the exponential regression equation. Now, I know you guys know how to do that. Going in here and going to the 0 option. But we can fill out, just because I want to go ahead and do the whole problem with you guys, y equals ax, a being 4.75. Based on the rounding we do in class, it's just 4.8, times b, 6.77, or 6.8 to the x power. And there is our equation that tells us, given the diameter, we know the breaking strength. I would like you guys to work on number 11 here. This is very similar. It's actually doing the exact same thing. The main objective is just being able to draw that scatter plot, have it accurately listed with information. Apologies, the writing is so messy there. This is not a very fine-tipped pen, and yeah, it looks like a mess. I'll give you that. Tomorrow, we're going to be working on these examples right here. Example 3, 4, and 5. We're probably going to do one of them together, and then you'll have a couple of those at that time. But for now, just try out number 11 right here. And I'll see you guys tomorrow.